Hello everyone, I'm Viveka Ramrakyani. I'm the head of materials for Costain Limited. I'm hugely passionate about sustainability and undertaking low carbon concrete solutions. Today I will be speaking about how we can implement low carbon concrete solutions and specifically from contractors' perspective. Now, the Romans made use of pozzolana, a type of volcanic ash, to make concrete from about 300 BC with the roof of the Pantheon, which was finished in around 125 CE, still the largest unreinforced concrete dome in the world. The first building in Britain to be built using reinforced concrete was Weaver's Mill in Swansea, completed in 1898. It used hand-built system, which quickly became the most widely adopted method across Britain and Europe. So concrete has been from centuries. It's the most widely used manufactured material on the planet. And typically, cement accounts for around 8 to 10% of concrete makeup, but it's accountable for the largest proportion of carbon emissions. Big emissions come from the production of cement. Cement is the one which is gluing and holding together the concrete. 40 of the world's leading cement and concrete companies unveiled a joint industry partnership. They came together to talk about the climate ambition to be achieved in 2050. The statement demonstrates the commitment of the industry across the globe to drive down the CO2 footprint of the world's most used man-made product, with an aspiration to deliver society with carbon neutral concrete by 2050. So that's the goal or the aim we are all moving towards to decarbonize. So, with us being contractors, we have looked into low carbon concrete solutions. We have issued materials guidance within our organization. I'm just going to highlight what we are trying to achieve to provide guidance within our organization to our people. This guidance has been stress tested with key suppliers, designers, and SMEs. This is our little bit as top down research undertaken. So, what we are trying to achieve? We are trying to say that we would be replacing 100% of OPC cement. It should not be used or specified for concrete mixes as far as possible. SEM1 may be used in some circumstances in combination with GGBS, PFA, or similar cement alternatives. So that's the position we are taking. Now, how do we achieve it? Couple of ways to do it. Either we remove all cement, we reduce cementatious content in concrete mixes, we rationalize early strength requirements, we increase percentage of secondary aggregates, we reduce transportation, reduce waste. How do we do that? The most foremost way to achieve that is early supplier engagement. That is the key. We need to reduce concrete wastage. As I've said it before, we have identified and issued the guidance to use lowest carbon concrete options available. We need to support the suppliers with technical information and guidance to advise the use of LCC. We need to work with the supply chain to forecast and increase the use of LCC. We need to support the industry, share the knowledge and the experience as we are coming all together on this wonderful platform to decarbonize. We need to develop eco partnerships by collaborating with academia. And all this can be unclogged by collaboration. So we have got the key to do it. We just need to come together. There are always opportunities of reduction of carbon emissions through providing different options. After collaboration, the next is implementation. No point talking about it, it's just going and doing it. Secondary aggregates have a lower embodied carbon. If possible, let's increase the content. Why are we still over designing the concrete mixes? Let's go on the drawing board again. Have a check. Current design codes are allowing for 80% replacement. So there's no excuse. You just got to do it. It's the two sides of the same coin, collaboration and implementation. We just need to take it forward. Now, there are a number of substitutes that can replace concrete and cement. Fly ash, GGBS, silica fume, calcined clay. We have currently used concrete mixes from various suppliers with 70% GGBS. On some occasions, even 80%. So, there is a large demand at present for GGBS. Now, that has driven the pricing up. So, we need to find alternatives to use of GGBS as well, as the supply is quite finite. So we need to look at various options of silica fume, calcined clay, which is the emerging material or has been the material already, but we need to make it work as a smart material for us for future. Permanent structures need to be compliant with the design codes, which can be a barrier to using some of the SCMs. So some of the SCMs which I've mentioned here are there. We have got Semfree, we have got Wagner's. 100% cement replacement can be achieved with alkali activated cementitious products. They contain a mixture of GGBS as well as some other alternatives such as PFA as well as activators as well. For temporary works, there are options to completely remove the cement from concrete. ASCMs are not currently approved by some of the design codes, but we can use PAS 8820 to achieve that. Considering the curing times for high GGBS replacement is quite high. But we need to start factoring that in within our program to achieve those. One of the examples which I have shown here is for Crossrail. This was when we were building Crossrail and we did one of the trials by using 50% GGBS in those days. So the journey has been started. We just need to take the steps forward. The barriers or the disadvantages which we had in those days are still relevant now to be achieved. This is an example from A14 Huntingdon to Cambridge, where we did trial Semfree. We have used it in small structures. We have used it as an alternative to air entrained concrete in road bridges and islands. We have also used EFC, earth-friendly concrete, in various applications on our projects as well. One of the examples, as I've shown on the screen, is at Thames Tideways. We have got an easy win on temporary works concrete mixes. But we have done a lot of work in achieving reduced carbon concrete mixes even for permanent works as well. As you can see in the graphs here, we have achieved 67% to 75% replacement. So 150 tons of carbon reduction, that is equivalent to 100 return flights, London to New York for a passenger. So we can see how critical and important it is for us as well. What are the steps to implement the change? Who, when, where, how, barriers? Who is the person responsible? Material experts, concrete suppliers, design experts, delivery team. We need to take bottom approach currently. That's what we are doing. What we need to do is bring down top-down approach. And again, I'll say it, collaboration is the key. We need to do it in the beginning, have a change request submission, client acceptance, things happen. That's what we have been doing currently. We have learned lessons from one project, we have shared it across other projects. As an example, change the cement type and replace it with the other alternatives. Agree for compliance, testing at 56 days instead of 28 days. We need to cross the barriers for specifications. and the longer curing times needed for high replacement cements. LCC, considered to be more expensive, but again, it depends on the requirements. Some occasions it's cheaper or equivalent. Long-term properties are at least as good in terms of the strength and durability. Early age strength is slightly delayed, so there is a potential impact on striking shutter, but no one size fits all. We need to check at every step which concrete we are using. Collaboration is critical. Together we can make our planet cleaner. Thank you. I open the floor to any questions you might have.
Thanks very much for that, Navika. That's really, really very, very interesting and very important. I've got a question in from the audience straight away, which is talking about education of clients, and wondering whether you've done any of that and how it's gone, and if you've got any tips for anybody who's dealing with a client to deal successfully with those conversations.
To be honest, the clients have definitely been at the other end. So now we are seeing national highways insisting on it for low carbon concrete. We are seeing high speed 2 giving, in fact, issuing guidance as well to say we should be using low carbon concrete as much as possible. We've got a performance spec in place which gives us the flexibility to go and use low carbon solutions. So there is a lot around their willingness from the client as well going forward. I hope that answers your question.
I think so, yeah. I guess one thing that occurred to me is just kind of to get the terms correct. Can we just define quickly what low carbon concrete is and whether zero carbon concrete is a realistic prospect, and whether that kind of involves a material that might not involve any cement whatsoever?
So in essence, low carbon concrete, we are looking at the entire life cycle of the product in essence. A heavy burden is in actually the making of the concrete, but there is also the transportation and other areas. So the emissions reductions in concrete can be achieved cumulatively throughout the materials, like full life cycle process of it. It's not just through a single change. You need quite of changes to be made to achieve that. In regards with zero cement, the demand for cement in the coming decades will likely remain consistent, which means there will be no additional value created from the traditional approach to the cement production. So as a result, everyone across the built environment must act now and explore alternative options to decrease both the costs and the carbon together.
Great. Okay, that's very clear. Thank you. And a big factor here, I guess, is this circularity argument in terms of, the industry, as much as possible these days, is repurposing buildings, but there's still a lot of demolition going on. What can be done there to help reuse concrete and prevent the need to be conducting processes that involve the creation of new concrete?
So I believe the cement value chain is now well positioned to create closed loops, or there are automatically regulated systems in place for carbon, for materials, for minerals, as well as for energy. With these points in mind, circularity can work jointly with reducing carbon emissions in cement production, because circular technologies follow the pattern of three crucial decarbonization strategies, which is redesign, reduce, and repurpose. So there is a lot we can achieve by the circularity concept going forward, certainly.
Fantastic. And are there opportunities there for contractors in terms of, do we need to see more of a creation of a market whereby demolition contractors are, selling materials to, producers or directly to clients or produce? Are there changes in that market that you think might help?
Some, but I think it's more sort of the other side of the thing where the concrete suppliers themselves are quite proactively looking at options of providing low carbon concrete solutions for the likes of Hanson, Tarmac. They themselves are quite keen to come with 70% replacement options, 80% as well. There are some occasions, as I said in my presentation as well, that we have
Yeah.
trialed those sort of mixes as well. So there is certainly a lot of keenness from the suppliers as well.
So where do you see this agenda in 5 or 10 years' time? I mean, do you see significant reductions being able to be made within that time period? And by 2050, do you think that 2050 goal is realistic?
I think that's where we are moving towards, or that's the goal we are all sort of working backwards towards it. And so currently, if we think about it, we have got the client, which is the sponsor, we have got the suppliers, we have got the contractors. So we all are trying to come together to make our planet greener. And I think together we will definitely achieve it.
Fantastic. That's been really, really interesting. Thank you very much. We could delve deeper into that, but I'm sure we will at some stage. Thanks for sharing your insight. Our next presentation will be from Sam Hillier from Gallagher Insurance, who's going to talk about the insurance challenges for using mass timber in new build construction.
Thanks for inviting me, Colin.